In today's class, we are going to discuss 4 graphs that are very important for our syllabus. So the first one today that we are going to discuss is the modulus function. F of x is equals to, this is called mod of x. This is defined as x whenever x is greater than or equals to 0 and minus x if x is less than 0. Let's take an example. Say mod of 2. Mod of 2, say x is greater than equals to 0, then the value is x itself, that is 2. If I say mod of minus 3.5, what happens is minus x is less than equals to 0, mod x is less than equals to less than 0. So whenever the x value is less than 0, we take this as minus x. So this becomes equals to minus into minus plus 3.5. Basically what modulus does is it converts negative number into positive, and if the number is positive, it remains positive. So let's look at what the graph looks like. Okay, so at x value 1, the value of f of 1 is 1. At 2, x, if I put 2, mod of 2 will be 2. Similarly, if I keep on going, I get a straight line in this way, where mod of 6 will be 6. So this is how mod of x for x greater than equals to 0 and for x less than equals to 0, mod of minus 1 is 1 because it makes negative number positive. Mod of minus 3 if I say, so that will be minus plus 3. So the negative number becomes positive. So we get a graph like this in case of the negative numbers. So this is the graph of f of x equals to mod of x. So the domain over here, in the x-axis, we can put any value of x and we'll get a value that is real. So domain will be the set of real numbers because we can put any real number over here, be it positive, be it negative, be it 0. But the range over here, if you see, is, so the range over here, we are getting from 0 and it is going to infinity, be it left, be it right. So it starts from 0 and goes to plus infinity. So the range will be 0 including 0 because f of 0 for x greater than equals to 0, it is x. So f of 0 is basically 0. So range will be from 0 to infinity. So 0 will be included. Second thing, f of minus x will be equals to mod of minus x, which will be equals to mod of x. If we take mod of minus x or mod of x, it's going to be the same because if it's say minus 3.5, so x is minus 3.5. So minus of minus 3.5 is plus 3.5. Mod of 3.5 is 3.5. And if I take only x where x was minus 3.5, mod of minus 3.5 is going to be 3.5 itself. So if I take mod of minus x or mod of x, it's going to be the same. What I'm trying to say is mod of 2 and mod of minus 2, both the values will be 2 itself. So it basically makes the number positive. So if I take mod of minus x or if I take mod of x, the number we are going to get will be the same. So f of minus x, we get the same as f of x. So this implies it is symmetric about y axis. So hence it is an even function. Even functions are symmetric about y-axis, and functions that are symmetric about y-axis are even functions. You can see that y-axis acts like a mirror, and just this is the mirror image of this, or you can say that this is the mirror image of this portion. So this y-axis acts like a mirror over here. The seventh function, the second function for today that we are going to discuss, is the signum function. So signum of x, this is the signum function, is defined as mod of x by x when x is not equals to 0 and is 0 when x equals to 0. Basically what does it mean is that, say if x is greater than 0, so mod of x is basically x by x becomes 1. For x greater than 0, the value of this is 1, is 0 for x equals to 0, and whenever x will be less than 0, mod of x will become minus x by x becomes minus 1. So for x less than 0, the value will be minus 1. We can write this also as our signum function. We can write this as well. Both are correct. So the graph for this will become so whenever x is greater than 0, so 0 is not included. For x greater than 0, the value is 1. So this is a constant graph that we are getting. When x is 0, the value is 0. So at x0, the value is 0. And for x less than 0, the value is minus 1. So 0 is not included, and for less than 0, the value is minus 1. This is also constant graph. So it's coming from over here, minus 1. It's at x equals to 0, the value becomes 0. This is an open circle because it's not included here. And at x greater than 0, it becomes 1. So again an open circle at x equals to 0 at 1, and it starts from here and the value is 1. So this is our graph for signum function. Here the domain is the set of real numbers. We can put any real number over here, be it positive, negative or 0. Second, in the range we are getting only 3 values, that is minus 1, 0 and 1. So the range is basically the set of values having minus 1, 0 and 1. Only 3 values that we get. Third thing, f of minus x equals to minus f of x. Say if you take, let's take examples. So f of 1, so mod of 1 by 1. See x is greater than 0, so this value is 1. And f of minus 1, so whenever value is less than 0, it is minus 1. So f of minus x is basically minus f of x. So this is first example. Second example, so f of 53 is going to be 1. For x greater than 0, the value will be 1. And f of minus 53, for x less than 0, the value is going to be minus 1. So f of x and f of minus x, if f of x is 1, then f of minus x is minus 1. So basically f of minus x equals to minus of f of x, which implies f of minus 53 equals to minus f of 53. So f of minus x is minus f of x, which implies it is an odd function. So it is symmetric about origin. Remember 8th graph and the 3rd graph for today. This is our greatest integer function. This is also called box of x. So f of x equals to, see, box of x. This is the greatest integer function. So, okay, we'll understand this with the help of some examples. Say minus 2.3 or say plus 2.3, box of plus 2.3. So let's say all the values of integers that is less than 2.3. So less than 2.3, the integers are, see, the integers will be 2, 1, 0, minus 1, minus 2, minus 3 and so on. So these are the set of integers that is below 2.3. And below 2.3, what is the greatest integer over here? 2. So since 2 is the greatest integer, so box of 2.3, that is the value of the greatest integer function of 2.3, will become 2. Another example, let's say find box of minus 7.9. So the set of integers that is less than minus 7.9. See, where does 7.9 lie on the number line? This is say minus 6, minus 7, minus 8, minus 9. So minus 7.9 lies somewhere over here. So the integers that are less than minus 7.9 are minus 8, minus 9, minus 10 and so on. And so on. So the greatest integer over here is minus 8. So box of minus 7.9 will be equals to minus 8. So this is our greatest integer function, and if we have to find the box of any integer, say 50, the box of any integer so will be 50 itself, because the greatest integer that is less than or equal to 50 is 50 itself. So any integer that is less than or equals to the given number is the greatest integer function. So box of any integer is the integer itself. Okay, so how do we have the diagram for this one? Okay, for any integer, the value is that integer itself. For value 0, it's 0. For 0.1, it will still be 0 because the greatest integer that is less than or equals to 0.1 is 0. So this comes still just before 1. So 0.999 if I say. So the box of 0.999 is also 0, because any integer, the greatest integer that is below 0.999 is 0 again. But as we come to 1, the value of box of 1 becomes 1, because the value of any integer, box of any integer, is that integer itself. Now 1.1, the value is 1, box of 1.1. 1.99 if I take, 99999 if I take, so that is still less than 2, and the greatest integer that will be below 1.999 is 1. So the greatest integer is 1, so the value of box of 1.99999 is again 1. So as it reaches 2, the value becomes 2, and similarly this keeps on going. And at 4 it will become 4, and like this. This is not there. Okay. Say box of -1 is -1, and say 0.1 minus 0.1. So the box of minus 0.1, if I say, so 0.1, where does it lie in the number line? 0, 1, minus 1, minus 2. So minus 0.1 lies somewhere over here. So the greatest integer that is just before minus 0.1 is minus 1. So box of minus 0.1 is minus 1. So this is minus 1. This comes till here. At 0 it becomes value 0. Box of minus 2, similarly we have minus 2, and any value from minus 1 till minus 2 will still be minus 2, because if I say minus 1.5, so the greatest integer minus 1.5, if I say, so the greatest integer that is below minus 1.5 is minus 2, because below minus 1.5 we have minus 2, minus 3, minus 4 and so on. The greatest is minus 2. So for minus 1.5 also it will be minus 2, and this will keep on going in the same way. So for minus 3 it's going to be minus 3, and till minus 2 it continues, and this keeps on going in the same way. So here this also looks like a ladder, so it's also called sometimes as the ladder function. Here the domain is equals to the whole set of real numbers, because any value of real number will give a value. The second, range. If you look at the y-axis, we are only getting particular point of numbers, that is minus 2, minus 1, 0, 1, 2, 3. What are these numbers? These numbers are the set of integers that we are getting over here. And let's take box of 0.9. So this is 0, and box of minus 0.9, that is minus 1. So f of minus x is not equals to f of x, and f of minus x is not equals to minus f of x. So neither of them holds. So we cannot judge this on the basis of symmetricity. So this is neither symmetric about origin nor symmetric about the y-axis. Though it may seem like it is symmetric about the origin, but it is not. Okay. The last graph that we are going to discuss, and the ninth graph, is fractional part of x. Or we denote this as curly brackets x. So fractional part of x is defined as x minus a box of x. So say fractional part of 2.3, this will be equals to 2.3 minus a box of 2.3. So this becomes 2.3 minus box of 2.3 is 2. So we get a 0.3. What we are getting is basically the fractional portion. If I take box of 25, so we get 25 minus box of 25, which is 25 minus box of 25 is 25 itself. So 25 minus 25 is 0. So if we take any integer, the fractional part of an integer is 0, because there is no fraction over here. If I take fractional part of a negative number, say minus 7.9, it is very convenient to say that the fractional part of minus 7.9 would be 0.9, but that is not true. Why does this happen? Is because this is equals to minus 7.9 minus box of minus 7.9. Now, if you look at the axis, minus 8, minus 7, minus 6, minus 7.9 is over here, and the greatest integer that is less than or equals to minus 7.9 is minus 8. So minus 7.9 minus of minus 8, the value of minus 7.9, box of minus 7.9 is minus 8. So we have minus 7.9 plus 8. So 8 minus 7.9 becomes 0.1. How much ever we find it convenient to write 0.9 as our answer for fractional part of minus 7.9. But for negative numbers, make sure you solve this properly and find it. If it's minus 0.9, we get 0.1. Say we have fractional part of minus 2.33. So we'll get this as minus 2.33, that is x minus box of minus 2.33. So this becomes minus 2.33 plus, minus this box's value is minus 3. So this is minus 2.33 plus 3. So 3 minus 2.33 is basically 0.67. So this is how we find the fractional part of x. So to write this in graph, okay, so at 0, any integers, fractional part is 0, 0.1 is 0.1, 0.2 is 0.2, and this keeps on going. As the value reaches 1, fractional part of 1 becomes 0. So we have an open circle at 1, it becomes 0. 1.1, the fractional part is 0.1. So this keeps on going like this. As it is about to reach to, say, 1.99, fractional part is 0.99. As it is about to reach 2, what happens is, as it reaches 2, the value again becomes 0. It never reaches 1, but it tries to reach 1. As it is about to reach 1, what happens is, it attains the value 0. So this keeps on going in the same way. At 4, the value fractional part is of 4 is 0. 4.1, 0.1. 4.2, 0.2, and this keeps on increasing like this. In this side also we have it like this, like for minus 0.9, so fractional part of minus 0.9. So this 0.9 is somewhere over here. So we have minus 0.9 minus box of minus 0.9. Now this is minus 0.9 minus fractional part of minus 0.9 is minus 1. So minus 0.9 plus 1, we have 0.1, 1 minus 0.9. So minus 0.9, we have 0.1, minus 0.5, we have 0.5, minus 0.1, we'll have 0.9. So this increases also in this way. So this is our graph for fractional part of x. Here the domain is a set of real numbers. We can take any real number. Second, range we have, it starts from 0, tries to reach 1 but cannot reach 1. It's just before 1. So range is starting from 0 until 1, excluding 1, because it never attains the value 1 in the y-axis. And see, fractional part of minus 0.9 is 0.1, and the fractional part of 0.9 will be 0.9 minus box of 0.9. Box of 0.9 is 0, so 0.9 minus 0, that is 0.9. So as we can see, f of minus x is not equals to f of x, and f of minus x is also not equals to minus f of x. So therefore this is neither symmetric about origin, nor symmetric about the y-axis. With this, we come to end of today's lecture. Thank you.